Atoms don't always have the same number of protons, neutrons, and electrons. Most of the time they do, but sometimes they don't. When the number of protons differ from the number of electrons, the atoms are called ions. But what happens when the number of neutrons differ? In that case, it's called isotopes. Isotopes are exactly the same as the original atom. For example, carbon-12 and carbon-14. The number represents the mass. Carbon has 6 protons, so naturally it has 6 neutrons. That adds up to a mass of 12, hence carbon-12. Carbon-14 has how many neutrons? However, because it has the same number of protons, it's still considered carbon. Therefore, anything that uses or absorbs carbon-12 can also absorb carbon-14. In other words, carbon-14 can be used as a substitute. Although nothing would naturally want to, but scientists can use isotopes for experimental purposes. Since isotopes have extra neutrons, the atom would want to shed off that extra neutrons. This results in radiation. Yes, in large quantity, but scientists are careful to use it in small amounts that aren't too dangerous. The use has extended to medical purposes. If you're sick somewhere and it's not something that you can see with the naked eyes, like an internal sickness, they can detect where the problem is. Doctors would give you isotope in a drink form. You take a sip, lay back, and then they scan you. When that isotope gives off the radiation, the scanner can show you where the isotope went. And we found the problem. One example are isotopes that are attached to cancer-detecting antibodies. Those antibodies are injected in the patient, and then it will go directly to the cancer cells. Then the isotope will give off small radiation, and we see where it is on the scanner to know where to treat the patient. To end the chapter, there is chemical reaction. That's when the bonds are broken or formed. The stuff that gets put in the reaction are called the reactant, and the stuff that comes out of the reaction is called the product. Chemical reactions are constantly occurring in your body, from digesting to converting carbon dioxide to bicarbonate. Chemical reactions are happening. Okay, that's it. Yay, we're done. With the first 2 chapters, now on to the next chapter. Before moving on to the next chapter, let's do a quick review. Ready? Brace yourself. Ready? Ready?